Welcome to Astronomy Daily Live for the 25th of May, 2018. It is 2 hours UTC on the 25th of May, 2018. Hey, everybody. Hope everybody's doing well. All is well here. We're doing all right. Sort of took the day off a little bit. Um, didn't get as much accomplished as I wanted because of various distractions that seem to always pop up. Hey there, Bobby. Nice to see you in the chat. Let's start up my live stream on my smartphone. So hope everybody's doing well. Doing well. Another pretty amazing day here in southeastern Arizona. It's sort of the driest part of the year. I mean, we really don't get any rain at all for sometimes several months until the monsoons start. Oh man, I don't have my I don't have my mug of hydrogen hydroxide. Wow. Okay. Well, we'll see how long I can last without extra that extra boost, extra boost. So I was watching Tony Darnell's coffee hangout um, this afternoon, and it was a good one. It actually was. I mean, all of his stuff. And a shout out to Tony over at Deep Astronomy. I think if you go to deepastronomy.space, I think that's his main website, and then just do a search in YouTube for Deep Astronomy. Um, he's doing some awesome stuff. Um, Good interviews. Um, Today I don't know if these were all the authors or just some of the authors of of the recent paper that I did. I'm pretty sure I talked about this in a live stream a few days ago too, um, about the plume, supposed plume that they um, detected coming from Europa using 20 like 21-year-old data from Galileo, from the Galileo spacecraft, and they saw sort of uh, um, a couple strange readings from the magnetometer and another instrument, and that whoops, sorry about that, and that prompted them to kind of go, I wonder what that is. Wonder what that is. And it's like, well, maybe it's a plume. Maybe it's a plume, you know, like a uh, 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 the result of a geyser of some sort coming off of Europa, and uh, and so I mean, got to have expended a huge amount of effort, um, uh, sort of on a hope, on a wish, on a desire to see if yes, indeed, what they did see was some kind of a plume, and yeah, the data matches the model pretty well. So it's sort of like, oh, pretty interesting, pretty interesting. But yeah, there was a discussion in there about you know, spacecraft data and accessing it, and you know, who knows, right? Who knows what else is sort of buried in this old data, right? This stuff was 21 years old. Well, heck, you know, we have spacecraft data from, you know, at least the 70s, uh, if not even earlier, right? And it's like, I wonder, right? I wonder. And the cool thing is that a lot of this data um, is available to anyone, right? You just have to go. Uh, well, you have to be able to find it, right? Um, you definitely have to be able to find it, and then you have to be able to, um, uh, you know, read it and interpret it, right? And then you have to be able to visualize it in some way. You know, make it uh, make it available to, you know, one or more of our senses. So, you know, we can, you know, maybe, well, you know, primarily astronomical data is visualized, right? But there are other ways. I've been working many years. It's a project of mine, you know, that sort of stews in the background because uh, nobody seems interested. Um, but that is, well, nobody seems interested in using actual data, right? They they like to use, you know, like models and things, but I'm I'm really keen on um, converting astronomical data and all kinds of other data to audio, to sounds, to music, um, and actually using sound as a um, um, analytical tool. You know, just like you would look at a picture of a galaxy, you know, maybe there are ways to listen to a galaxy and and actually get different kinds of information. But you know, nobody seems interested in that. So you know, I probably haven't tried hard enough, you know, to spread that word around. But you know, other people who are sort of doing the same kinds of things and seem extremely popular. Um, uh, I get pretty much the same um, um, response all the time, and usually the sequence is like this. Okay, I will say, um, um, I'll contact them, right, and I'll say, hey, I'm working on a thing extremely similar to yours, but you know, different in particular ways. Uh, Here's a sample. What do you think? I get almost an immediate response back saying, "Wow, that's awesome. We should work together." You know, lots of projects, lots of possibilities. Yeah, and so I write back and I say, "Cool, let's hook up." And then it goes silent, right? Nothing else. It's that scenario has been repeated for me over and over and over again so many times that it's like, whatever, whatever. But I think what I'm doing is moderately interesting. And, if somebody eventually picks up that ball and runs with it, and makes it available, to scientists and to people, um, then that's cool. I mean, I don't have to be, you know, um, the one to do this first, or the one to spread the word about it. I guess I'm just no good at those kinds of things. I don't know. I don't know. But anyway, so that's sort of a tangent. So that discussion during Tony Darnell's coffee hangout about about how, this data from spacecraft um, is available um, to anybody. You just have to be able to grab it. You have to be able to read it, and you have to be able to, you know, display it in some way. And it's like, you know what? I've been doing that for years, right? So that sort of inspired me today to go back and look at that a little bit. Um, and and so I went back the the one of the instruments on a spacecraft called Juno, which is currently in orbit around Jupiter. It's it's making these big long orbits. I think one orbit is like 53 days, but what they do is every 53 days they swing the spacecraft around really, really close to Jupiter. It's called Parajove, right? I mean, it's the closest approach to Jupiter in that orbit. And so, yeah, they do that so they don't have to subject the spacecraft to like um, um, continuous amounts of um, high radiation and all of that. So they sort of dip in fast, and then they get out, and they go slow, and they zip around again, and they zip around again. I think they've done it like 12 or 13 times now. I forget exactly. And one of the instruments on Juno is what's called a fluxgate magnetometer. And what it does, very, very simply, is it measures the magnetic field strength in 3 dimensions, right? In X, Y, and Z. I'm not quite sure what the uh, what how those axes are defined, if they're defined in terms of like the center of Jupiter, um, uh, you know, some kind of a solar thing. I'm not exactly sure, but they have these measurements, right, in X, Y, and Z, and they have it in terms of magnetic field strength, and they also have the XYZ, what's called planetocentric position, and um, that's a position like on the surface of Jupiter, on the surface of Jupiter. So as Jupiter rotates about once every almost 11 hours or so, um, uh, um, the the spacecraft appears to go, to circle around Jupiter. Hey there, Patrick. Jules is live now too, huh? Cool, cool. Well, you're gonna have to do the ninja thing and watch us both at the same time. No problem. So anyway, so I'd actually created some artwork from this data, a very very small sample um, of that data. Not quite a year ago. Don't remember exactly. Maybe 8 months ago, 9 months ago or so. Um, that turned out interesting. So it's like, okay, all right. Well, you know what? I'm gonna look at that data again and see if I can make sort of a similar kind of um, um, visualization, some kind of other interesting thing, right? And so I looked at Parajove. Well, at the days before Parajove number three. Now, Parajove number three happened on December 11th, 2016. Um, and what I did is I looked at um, data. I don't remember exactly what days these are, but they're day numbers 321 to 341. So 21 days, sort of. Uh, I think day number 341 is around like December 6th or so. So my data ends about a week before Parajove 3, and then extends about 3 weeks prior. Um, and so what I do is I take the position data, right? Well, in the example I'm going to show you, um, just the XY values um, relative to this position on Jupiter. And then I take the magnetometer readings and I convert those to an RGB color. And then I plot position versus magnetic field strength in color. And let me share my screen here. Hide that. Go over here, and that's what I get. I'll open this up totally here, so you can take a look and see what that looks like. So there you go. It starts on the outside, and from the perspective of a position on Jupiter, Juno seems to be spiraling in, right? So you can sort of see that the gaps here are getting wider and wider as Juno spirals into Parajove. But what you can also see is that the magnetic field strength, which is shown as a color, right, is shown as a color, uh, is very complicated, right? Very complicated. Very, very cool. So, yeah, just, I mean, this is a way to visualize sort of what's going on in a very, very complex um, environment. And I, I think it's fun and very, very cool. Hope you like it too. You know what? I'm going to take a quick break and I'm going to get some hydrogen hydroxide. So I will be right back. Hold on. I will be back in like a minute. So yeah, I sort of hope you like that. I think it's extremely interesting, and I think it's also extremely useful. And I also think that regardless of how I try to show these kinds of things off, I don't really think anybody cares. So they're going to do their own thing, and I guess I'm just going to continue to do mine. So, but I think that is very, very cool looking. So, and I think that there is some useful information in there as as well. So, but you know, I I don't know. You know, it's just art. Yeah. So I think I was since we're here, let me. I just wanted to give another plug to archive.org. This is a very, very, very amazing site. If you're not aware of archive.org yet, um, uh, you should, especially if you're really into any of the sciences, mathematics, computer stuff. Uh, these are absolutely amazing, and this is an up to date archive of all of the latest and greatest, bleeding edge papers on uh, a number of topics, right? Not just like astronomy, right? But uh, lots of different kinds of physics, mathematics, computer science, biology, finance, stats, um, um, electrical engineering, um, economics. So this is sort of the, you know, as I said, the bleeding edge of a lot of really, really, really awesome and cool research. So if you aren't aware of archive.org yet, I am making you aware now. Cheers. So these are usually updated every weekday, right? So Monday to Friday. And what I've observed is that they usually are updated some sometime between 1 and 2 hours UTC every weekday, right? So Monday through Friday. There are no updates on the weekends, right? So you have to hold your breath and hope that you don't turn blue until Monday. So sometimes that feels like a long, long, long wait, but usually there's between 20 and 40 new papers every single day, and uh, most of them are mind-bendingly just awesome, right? Just incredible, incredible work, and yeah, I can't say enough about all these things. This is how um, uh, I and most astronomers, keep track of sort of what's going on in the astronomical world. And so yeah, this is a great way, to keep informed and to also, I mean, you know, as I say, a lot of this stuff is really, really way over everybody's head, right? I mean, a few people on this planet can sort of understand some of these things, right? So, I mean, fully admit, right, that most of this stuff is way over my head, um, way over most people's heads, right? But my criteria is this: it can be over my head. In fact, I sort of prefer it being over my head. I'm going to stop sharing so I can show you what I'm talking about, right? So, I mean, it can be over my head, right? But my criteria is that I have to be able to reach up over my head and at least get a fingertip, right? At least get a fingertip on that thing, right? Just a little bit of a stretch, and it's like, oh yeah, okay, I can sort of touch that a little bit, right? So anything between sort of arms out and top of head, right? That's where I want to be, right? That's what sort of keeps me motivated, keeps me interested, right? Because I mean, if I'm hearing things, right, that I already know, right, and I'm just hearing it over and over and over again, it's like, you know, go away, I'm bored, right? But uh, if things are sort of over my head and about that much, then it's like that's very very cool. Now, if some of these things are totally out of reach, then I sort of have the same response. It's sort of like, well, I guess that's kind of interesting, but I don't get it. I mean, it's so far out there that I can't do it. And I know that a lot of people have the same kind of thing, and that's why I say you know that if you want to get into this, grab these kinds of papers and look for the pictures, right? That's what a 3-year-old does when they are beginning to learn to read and comprehend things, right? Is that you go for the picture books, right? And I am recommending exactly the same thing. It's like, you know, uh, find one of these journal articles that you know look at the title, right? And it's like, oh, okay, well, that's kind of interesting, right? And then read the abstract. That's that paragraph or so right underneath the title. That that will give you sort of a general overview. It's like an executive summary of the entire paper. So take a look at that. See if there's anything that sort of catches your interest. And then before you do anything else, start looking for pictures, right? Look for images, look for plots, all of that. Read the captions and see if you can understand those. This is what I do, and I thoroughly enjoy it. And even if I don't really have a good grasp of the paper itself, because it is way over my head in most instances. Looking at the pictures is like, okay, I sort of am getting an idea about what they're talking about here, and that's something to grab onto, right? And if you want to have an understanding of things, you've got to be able to grab onto it. So all right, well, cheers. Cheers to pictures. All right, well, cool. I think let's do another object of the day, and let's do one from the Messier catalog this time. That pretty much ensures that pretty much ensures that we're going to get a lot of information. So let's do that. So there's 110 Messier objects. We're going to go to random.org, not a random.org, but just random.org. And we're going to have this site choose for us an integer between 1 and 110. You ready? Now, last night I forgot the drum roll, and that's probably why it was such a bummer. So, but with Messier objects, we're pretty much guaranteed something pretty interesting. So, all right, here we go. Ready? Drum roll, please. 110. I think we did 110 once. I'm going to do another one. You ready? Here we go. M45. Do you know what M45 is? That's an easy one. That's an easy one. I'm sort of inclined. I'm sort of inclined to pick a different one too for this one because M45 is the Pleiades, and everybody talks about the Pleiades. What do you think? Should we try another one? All right, let's try one more. All right, how about M55? M55. Let's go over here to Sinbad. And let's look at M55, Messier number 55. M55. Globular cluster. Yeehaw. Yeah, I think this is down in, I think it's down in Sagittarius, isn't it? I think so. I think so. All right, well, let's take a look at this bad boy. And we'll definitely see if there's any HST images of this too. There's obviously a digital sky survey. There might be a Sloan digital sky survey. Nope. 2-mass image. There's a 2-mass image too. That's kind of cool. Anyway, so celestial coordinates, 19 hours, 39 minutes, 59 seconds, and a declination of negative 30 degrees, 57 minutes, 53 seconds. Okay. And it's, it's in terms of galactic longitude, it's pretty close to the galactic center, but it's south. It's south of the galactic center by about 23 degrees or so. It looks like it's, at least we and it are moving away from one another at a pretty good clip, 174.9 kilometers per second. That's not incredibly fast, but yeah, that's still moving fast, relatively speaking, right? And so it has a V magnitude of 6.5, which the V filter is around 5,500 angstroms or so, and then it has a K magnitude of 3.69, and K, I don't remember exactly where K is, but it's around like 1 micron or so. So it's moving towards the infrared, right? So interesting that the infrared magnitude is brighter than the visual magnitude. What that usually indicates is that these objects are, as they say, quite red. Quite red. They're brighter in the red than they are in the visual. So yeah. And I think that makes sense, you know, because the idea there is that the stars that make up globular clusters uh, are thought to be old, and old stars are usually pretty red. So yeah. All right, there's the various other names for M55. It does have an NGC number as well, 6809. Pretty typical. Quite a few references, which I'm not surprised. Let's see how far away they think this guy is. They always do it in megaparsecs, which is, I don't know, for galactic things that just seems a little extreme. But all right, so a megaparsec is 3.26 million light years. 26 times 10 to the sixth times 0.005. So that's putting it at around 16,300 light years away. So yeah, it's not incredibly far. It's not incredibly close. It's sort of average for globular clusters. The um, the globular clusters, they sort of hover around the galactic center, or congregate around. Um, they make up what's called, you know, the so-called halo, the galactic halo, and so yeah, you know, the fact that M55 is about 16,000 light years, that puts it about halfway between us and the center um, of the galaxy. Of course, also in the direction of the center of the galaxy as well. So that all makes sense. So this globular is um, 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 between us and the center of the galaxy. Very cool. I don't know if there's any interesting observation logs here. Looks like they're already being shown. Let's see. I have no idea what this is at all. Um, it's the Newton observation log. That's probably some kind of, I think that was some kind of X ray telescope. I don't know if there's anything interesting to see there or not. Nope, that's a FITS file of some sort. Let's look and see what this is. That's some kind of other file. All right, forget it. That's another FITS file. So yeah, I'm not seeing much. Here's something. Yeah, that's not incredibly interesting either. All right. Oh well. Let's see. What else do we have here? Let's see if HST let's see if HST has any images of M55 for us. So we'll look at imagers and spectrographs just for fun. If there's any spectra, that would be kind of cool to look at. So M55, it's gotta be, yeah. So I like to sort these by date, so we can see sort of the latest ones, and then so these are with oh, and look, there are some 3-color ones too. So theoretically, I could put these together into an image. Not quite sure what we're seeing here though. All right. Not. I'm just seeing a nice rich star field, which is fine. Maybe they're looking a little off center. I don't know. Let's look back. Those were observations from 2014. Let's look at the 2007 observations. Let's see if there's anything different here. M55. Okay. This is obviously from whiff pick 2. Kind of messy there in the center. But that's astronomical data for you. Sometimes it can be a mess. Looks like all these are the same proposal ID. Yeah. So let's go down to this and see if there's something different. So M55 must be a pretty loose globular cluster, because so far I'm not seeing like huge concentrations. I mean, that's showing I guess a little bit of concentration, but I don't know. Let's go back over here and see, that's showing the digital sky survey showing a pretty dense area. 2MASS wasn't showing quite as dense, but still. Just went back to the digital sky survey image for some reason instead of 2MASS. It's not showing what I want to show. It's a nice looking globular for sure. Well, I see you lurking there, Heptacular Raptor. Nice to see you. We're just looking at M55, and I guess I'm trying to understand why the HST images aren't as exciting. Oh, that's kind of interesting. They took an exposure either unguided or the telescope was moving. Oops. Yeah, wow, I don't know. Let's look at this one, I guess. Yeah, I don't know what's going on there. Huh. Always little surprises. Let's go back to 1995, I guess, and just sort of see what's going on there. Ew. Terrible, rotten. And yeah, well, that's astronomical data. That's how it is. For sure. Let's look at this more recent stuff. Wow, I guess this is just really zoomed in, so we're seeing, I don't know. I mean, I'm really having a hard time seeing any like concentration of stars here at all, right? I mean, we're looking towards the galactic center. So, I mean, we're going to be seeing a heck of a lot of stars, right? But supposedly supposedly this is looking at M55, and I don't know. I'm not buying it. I'm not buying that this is M55. Unless it's just, yeah, I mean, M55 is pretty big, right? I mean, it is pretty big. It's like almost 6 arc minutes in size. And well, let's do this. Okay, this is with pick 3. Okay, let's look and see what the field of view for with pick 3 is. Because it might just be a scaling thing. I've got certain biases, expectations in my head with pick 3 field of view. Let's see. Instrument handbook, I guess. Field of view. Pick 3. So it's 162 arc seconds on a side, right? Which is about 3, not quite 3 arc minutes on a side. So, yeah. If this, I don't know. I'm a little confused. Just a little confused about that because I don't see any concentration of stars there whatsoever. And a globular cluster is definitely going to show a concentration of stars. So I don't know. Yeah, that's very strange. Sort of frustrating too, because the HST images are always pretty awesome, but it's like, well, there's nothing there. I mean, it's a rich field of stars, but yeah, we're looking near, or near at least the disk of the galaxy, so we're going to be seeing a lot of stars. Yeah, that's very confusing. And that's just absolute garbage. Look at that. These poor guys didn't get any good data at all. Oh, well, they're taking half a second exposures. What do you expect? Look at that. Half second exposures. What are these guys doing? That's insane. Let's look and see what these guys are doing. We can look at the proposal abstract, okay, for proposal ID 10524, University of Bologna. This proposal is part of a coordinated project devoted to understand the interplay of globular cluster dynamics and the formation and evolution of blue straggler stars. Um, by using a combination of HST and ground-based observations, we are constructing complete blue straggler star surveys in a sample of globular clusters. Up to now, only 4 clusters have been surveyed in this way, and the results are surprising. In 3 of them, we've discovered that the blue straggler star's radial distribution is bimodal, highly peaked in the cluster center. All right. Well, yeah, I don't know, you guys. I mean, looking, taking half-second exposures. I don't know. That's not going to get you anywhere. So I don't know what they got at. I mean, they took a couple of 40-second exposures, but yeah, we looked at those and those look. Yeah, those are the streaks. So what? What? Yeah, that's insane. These guys took valuable HST time, right? They took 100 no 82 82 seconds of HST time and got nothing. Yeah, I don't know. That's a little strange. Isn't that strange? Look at that. Useless. And that's the only proposal number, 105. Oh, okay. They looked up here too. Okay, so here's a few more that is also theirs. All right. Well, that makes a little bit more sense. Okay. So there they're taking some longer exposures. Okay, very good. But again, wow, I'm not seeing a concentration of stars. Wow. Now this is with pick 2, so I'm not sure what the field of view is here, but it's probably going to be pretty similar. Huh. Interesting. All right. Well, I guess I'm not going to dwell on that anymore. Gee whiz. Try to do something interesting and it just blows up on you. Let's take a look and see if there's any interesting papers. And then I'll let you guys go. Could you be subpopulations? Okay, that's not the same object. Evolutionary history of 4 binary Bluestragglers in 4 clusters, including M55. All right, well, let's take a look at that one then. Maybe these are the same ones. Are they? Let's find out. We've got the names. We've got the names. We've got the numbers. Let's look and see if these are the same. No. This is Francesco Ferraro, and yeah, this is somebody else. So, oh well. Okay, let's look at the reference in the astrophysics data system. And hopefully there's a paper that we can grab. Oh, they changed their. Let's see if this works this time. Ah, they got it working. Last time, remember, we tried that and it failed. So yeah, it looks like they fixed it. So yeah, Bluestragglers are kind of interesting things, right? These, you know, as I was saying earlier, the idea with globular clusters is that these contain very, very old stars, right? You know, um, stars that may have formed at the same time as the galaxy itself, right? So these are really, really old stars, meaning that they're very evolved, right? So most very evolved stars are red. They're red and cool. But when we go and observe globular clusters, what we see are these blue stars. We see blue stars and yellow stars. And it's like, what is going on? Right? What is going on? And I don't think that there's really consensus yet as to what is going on. But I think at least one of the theories is that um, two or more stars are merging, and that creates a higher mass object, which increases the temperature and therefore changes the color back to a blue, burning hotter. So yeah, I think that's at least one of the theories. So let's see. Let's look at. Let's see if I mean M55 is in the title, so I assume that they do mention M55. Yeah, M55. So they're saying that M55 is about 12.3 billion years old. Wow, that's pretty old. So let's see, the RGB of M55 is split into ultraviolet, suggesting the presence of two subpopulations. Okay. This is a pretty long paper, so I'm just gonna M55 and 55. I'd like to see some like color magnitude diagrams, but a lot of this stuff is just models, lots of various models. Let's see. The best fit models of V60 and M55 V228 are too massive for the age of the parent cluster as it's currently estimated. Okay, so they've got some funny mysteries there. That's cool. I like funny kinds of mysteries. That's about it. All right, well, cool. So, yeah, at least they're finding them in this particular globular, and yeah, maybe there's some interesting things. Their models aren't matching their estimates in terms of ages and all of that. So yeah, that's pretty cool. I'm not even gonna try to get into any of this. This is uh, this is painful. Looks like they're looking at. I'm not quite sure. It looks like they're looking at like binary stars. Not quite sure. I don't think that the actual merger of stars has ever been observed. So I think that's still a theory. If there's anything else interesting here. Yeah, these are just models. Wow. Yeah, well, as I was saying, this is one of those papers that really goes so far above my head that it's like, I don't know. Discussion. We've reproduced the present configurations of the considered systems, assuming conservative evolution of isolated binaries. Um, Obviously, this result does not prove that these binary stars are formed in this way. It just indicates such a possibility. Okay. They have any conclusions? Yeah. The results of the present investigation demonstrate an importance of the close binary evolution in the formation of blue stragglers. In particular, it was shown that blue stragglers result from rejuvenation of an initially less massive component fed by the hydrogen-rich matter from its companion overflowing the inner Roche lobe. Yeah, so maybe not mergers per se, but at least in these binary systems, they're saying that there is material that is going from one star to the other. So number two, to reproduce the present parameters of one of these binaries inside of Omega Centauri, it was necessary to increase the helium content. Okay. Right. So the best fit models for one of the binaries in M55 is too massive for the age of the parent cluster. So unless this is an apparent effect resulting from an inconsistency between models, these systems may belong to younger subpopulations. Huh. Okay. So yeah, they're comparing models to models, and oh man, yeah, that can turn into a mess pretty quickly. All right, well, I think I'm gonna get out of here for this evening. Yeah, I think I'm gonna go have some late dinner. Late dinner. I'm starting. Yeah, getting hungry. Getting hungry. So, all right. Well, I'm gonna get out of here. So, peace. Take care. Have a great evening. A great day. Spread the word. Spread the word. Every single day I am here. 2 hours UTC. I don't foresee any change in that at all. So yeah, we will do it again tomorrow. I have observed that tomorrow does come so far, so I'm can be pretty sure that I will be here again tomorrow, same time, same place. So hope everybody has a great one, and I will see you again in a little less than 23 hours. All right, I'll see you on the spin. Bye.